Welcome to video 12.4a, volume of prisms and cylinders. We have a whole bunch of formulas to go over, so let's get started. First, the volume of a right rectangular prism, as shown here, is simply the area of the base times the height. Now the volume of any prism, does not have to be rectangular or right, is also the the area of the base times the height. So notice I've got this stack of index cards. The volume is simply all the index cards. If I were to slide the index cards like such, it has the same base area and the same height, so it's going to have the same volume. All the cross-sectional areas are the same, that rectangle. So in general, the volume of any prism is the area of the base times the height. And that comes from Cavalari's principle. The volume of a cylinder is also the area of the base times the height. Cross-section. Let's go over what a cross-section is. You might recall from Algebra 2 conic sections, we had a cone, and we dealt with some cross-sections. First, if we cut the cone parallel to the base, we obtain a circle. If we cut the cone at an angle, such as this, we obtain an ellipse. If we cut the cone such that it's parallel to one of the edges, so I'm going to cut it here, parallel to this edge, we get a parabola. The hyperbola is too difficult for me to do. It's if you cut both top and bottom. In this book, for cross-sections, we're going to talk about cutting always parallel to a base. So let's suppose I had a log like this and I took my saw and cut it. That would be the cross-section. If I had a hexagonal prism like this and took my saw and cut it, that would be the cross-section. Again, getting back to another type of example, if I had an egg shape like this and I cut it, that would be the cross-section obtained there. So the cross-section in our book, we're going to talk about, it's the figure obtained when you cut a solid parallel to the base. So our book is going to use a certain symbol. And for cross-sectional area, our book uses a C with a slash through it. So based on all of that, the volume of a prism or a cylinder based on cross-sectional area is simply the cross-sectional area times the height. So this is kind of like the area of the base. And as one more example, here are two triangular prisms. They have the same height and they have the same cross-section, so they will have the same volume. The volume is simply the area of the cross-section times the height, or in this case the area of the base times the height. There you have it, a little bit of vocabulary on cross-section and some volume formulas for various solids.